Let's talk about some ratios in some iconic triangles. This book refers to the isosceles right triangle as the 45, 45, 90 triangle. The other iconic one is half of an equilateral triangle, which is a 30, 60, 90 triangle. The thing you want to avoid that I'm going to mess up a bunch is I'm going to say 30, 60, 90 right triangle, which is like saying pin number. The N stands for number. So you don't want to be like, oh, pin number, because that's your personal identification number. That's too much N. So don't be like, oh, 30, 60, 90 right triangle. When you said 90, you said right. Just 30, 60, 90 is good enough. That's all not that important. In the 45, 45, 90 triangle, it's isosceles, two sides are the same, and that means the two angles are the same as well. And since the two acute angles of a right triangle have to be complementary, each one has to be 45 degrees. Here's what we know about the ratio of the sides in an isosceles right triangle. We know that the two legs have to have the same measure, and the Pythagorean theorem tells us that the hypotenuse is √2 times as long as a leg. So the ratio of the sides in a 45, 45, 90 triangle are 1, 1, and the square root of 2. We also know the ratio of the sides in a 30, 60, 90 triangle. So in a 30, 60, 90 triangle, one of the angles is 30, and then the other angle must be 60. In a 30, 60, 90 triangle, there's a short side, a medium side, and a long side. The long side has to be the hypotenuse. The short side has to be opposite the 30 degrees. Janet, Peter, we don't care about. Let's mention it. The middle angle, 60, will be opposite the middle side. The ratio of the sides, start with the short side opposite the 30 degrees. That's going to be 1. The hypotenuse will be twice as long. And opposite the 60 degree, the Jan angle will be the square root of 3. So if the short side is x, then the hypotenuse is 2x, and the middle side is x times the square root of 3. We should recognize the numbers square root of 2 and square root of 3. At least some of the digits. So let's see, the square root of 2 is 1.414. That's good enough. And the square root of 3 will be 1.732. We should recognize those decimal approximations. So √3 is approximately 1.732. And the square root of 2 is approximately 1.414. So here's the list of stuff that we want to know. We want to be able to recognize the sine, cosine, and tangent of a 30, 45, or 60 degree angle. Now, this is your times table for trigonometry. This is just stuff that you get to know now because you're in trig. So you want to know it is time to know sine, cosine, and tangent of 30, 45, and 60. We're only going to be adding to this. So this is where we're going to start with these two iconic triangles. All right. So let's remember our trig ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if I take this 45-degree angle down here, opposite is 1x, and hypotenuse is x times the root of 2. So I get 1x divided by x times the square root of 2. I get 1 over the square root of 2. This is a perfectly acceptable way to remember the sine of 45, but it's not the common way that we're going to remember the sine of 45. You may or may not remember from algebra that it's not simplified if there's a radical in the denominator. That's not considered simplified. So we have to rationalize the denominator. So it might be that you see instead of 1 over the square root of 2, you might see this written as square root of 2 divided by 2. Note that a 2 by itself is 2 square roots of 2. A square root of 2 times another square root of 2. 2 factors square root of 2. So one looks like 1 over x squared. The second one looks like x over x squared. But you want to recognize the sine of 45 is either 1 over root 2 or root 2 over 2. The cosine of 45, if I look at this 45, adjacent is 1, hypotenuse is root 2. So I'll have 1x over x root 2. Cosine of 45 is also 1 over root 2. That makes sense. Cofunction of a complementary angle will be equal. So you now know that sine of 45 is root 2 over 2. Cosine of 45 is root 2 over 2. Tangent of 45 is opposite over adjacent. Tangent of 45 is equal to 1. How's everybody okay? We want to do this sine, cosine, and tangent for the 30 and the 60 in this triangle. So your job is going to be to fill out sine of 30, cosine of 30, tangent of 30, then sine of 60, cosine of 60, tangent of 60. These are all values that you should just recognize. You don't have to memorize all these values, you just have to remember them. If you personally would like to remember them by memorizing them, then that's your choice. You just have to remember. Any questions? First thing that I'm going to ask about on Thursday is we're going to have sine, cosine, and tangent of 30, 45, and 60. This is going to be a chart, and we're going to fill it out. It's just a question of know your value. I want you to know the sine, cosine, and tangent of 30, 45, and 60. You can do this visually by knowing what these triangles look like. Some people find that helpful. Some people find it helpful just to organize the lists, make lists, and recognize the things that are going to be the same. You're going to find that sine of 30 is a half. And so cosine of 60 is a half. You're going to recognize that cosine of 30 is √3/2. Orange and purple will go together. Cool. And so sine of 60 is √3/2. The ones that came up earlier are tangent. So you're going to recognize that tangent of 60 is √3 like we did earlier. And tangent of 30 is 1/√3, which is also known as √3/3. You're going to have to find a way that's going to work for you. Some people are all about memorizing the pictures or remembering what the pictures look like. Some people look for patterns. I remember that sine of 30 is a half, and then it's √1/2, √2/2, √3/2. Then I just have to remember one. Then I remember my cofunctions of complementary angles. Cosine of 30 is √3/2. Cosine of 45 is √2/2. Cosine of 60 is √1/2, otherwise known as. The tangent, I remember the 45 is in the middle, that's the 1. √3 is bigger, it goes with the bigger angle. Tangent of 60 is √3. Tangent of 30 is 1/√3. Or if I'm trying to fit in √3/3. Any questions? Try remembering them in the different ways to see which one works best for you. It might be that you're just like, oh, no, I'm just going to have to memorize this by writing it down a bunch of times. Might be the case. I don't know how you remember stuff. What I should do is put this to a song, and then it'll be easier to remember. SOHCAHTOA is good. You remember the pictures in SOHCAHTOA, then you'll remember your opposite, adjacent, hypotenuse. And then you just have to remember which triangle you're dealing with and which is opposite. You will have to remember the ratios, 1, 2 in the square root of 3, and then 1, 1 in the square root of 2. But yeah, that'll work. Yes. That will depend on what we're trying to do. So in this problem, since we're trying to learn our 9 numbers, our 9 ratios, we kind of need both triangles. The reason that we use 60 in the windshield problem, that's just going to be the windshield problem now. The reason that we use 60 in the windshield problem, because I saw tangent and the square root of 3, and I immediately thought it's a 60-degree angle. That jumped out at me, right? That's why it jumped out at me. I saw that square root of 3, and then I looked at the problem and said, I see your game, you rogue. You are giving me a 60-degree angle without telling me it's a 60-degree angle. Tell me it's a 60-degree angle without telling me. And the angle is square root of 3. And I put the tangent and square root of 3 together, and I know that the thing that fills out that trio, 60 degrees. And then once I had that 60 degrees, this was the picture that I had in my mind. Although the way it was in the problem was it was turned this way. And it was also flipped. Any questions? How's everybody okay? Everybody looks stunned. Everybody's like, oh. Don't worry, it's only like 3 or 4 more hours today. I'm just kidding. If you want. All right. So that is your job for Thursday. Go back, fix any problems on the homework, find out if you still have questions on any of the homework problems. You could spend the next couple of days being mad at me for giving you an undefined angle to find and not telling you that one of the answers is there is no answer. Dick move on my part. You can throw your calculator at me, that's fine. I've accepted my role as the villain in the math class. So the only reason that I don't have like the Snidely Whiplash mustache is that I can't grow that much facial hair. But heck, if I could, I'd be like, oh, so it looked like we're going to have a quiz today. I mean, it'd just be easy to identify. I'm also not wearing a tie. Oh, maybe I should just wear a tuxedo with a top hat and shit. And like come in here and on the first day, just tie a student to the railroad tracks. Like, oh, let's see you escape this. Here's a quiz. That's how you do it. And kind of run off. Any questions? All right, that's going to do it for today. We're not going to have the supplementary meeting because we've already talked about the algebra stuff that we want to talk about. The algebra stuff that I wanted to talk about was this. So thank you for asking the perfect questions. You always fall directly into my trap. It's awesome. I wanted to talk about this conversion business, and I wanted to do some more sine, cosine, tangent angle. That's going to do it for today. I will see y'all on Thursday. Learn those 9 values. Everybody have a good 2 days. Thanks for playing.